Okay, so now we need to remember our terms, independent, dependent, and control variables. What is the independent variable? Okay, it's always easier to figure out what's a dependent variable first. So if we go up here, he predicted that the rise in temperature would depend on the volume of water. So what's doing the depending? It's the rise in temperature that's depending. The rise in temperature will depend on the volume of the water. So this is the rise in temperature. It's the dependent variable. It's the one that's doing the depending. Now some of you weren't even sure how to pick out the two variables. But the two that are in here, it's in this sentence, he predicted the rise in temperature would depend on volume of water. So if he changes the volume of the water, he can decide how much water to put in. He could put 20 mils in one cup, 30, 40, it's up to him. He's going to change that and he's going to see the effect it has on temperature. So the one that he's in control of changing, that's the independent variable. So this was the volume of water. What is a control variable? So a control variable is one we keep the same, but you could give specific examples. So for example, we would want to keep the same size candle. We'd want to keep it the same distance from the block and burn it from the same distance. We'd want to stir it with the same consistency. So lots and lots of things. You could do it in the same room. You could use the same material for the beaker. All the things that you will keep the same are control variables. So you just needed to give an example in there or define it as a control variable. Okay, Luke recorded his results in the table as shown below. So we can see here we've got the volumes of water that he chose. Remember, it's an independent variable, so he chose it. He did 25, 50, 75, and then he looked at the change in temperature. So why did he need to know it? So he could see how much the temperature had risen. Okay? Some of you mentioned it being fair, like it wouldn't be fair if we only wrote the temperature at the end because it might have started at a different temperature. And so as long as you explained that, not just said it was fair, but said that it had to be fair so that you could see the rise in temperature, then you got the mark. Okay, we'll go on to the next page within this video, so you don't need to change videos yet. Okay, so did Luke's results support his prediction and explain your answer? Yes, Luke's results supported his prediction. Why did they? How do we know they supported his prediction? Because the larger the volume of water, the less the temperature increase. So you needed to see the pattern, okay? So explaining your answer is all about just describing the pattern that you could see there. Luke stirred the water during the experiment. How did this make his results more reliable? So here the word reliable, we've learned it to mean repeating the measure many times, but it can also mean more consistent results. And you all got this right. This was a fine question. It spread the heat throughout the container. This question was hard for you. The same amount of energy went into all three beakers. The candle was the same. The thing was, yes, the temperature increased the most in A, but that's because there was less volume. And in beaker C, it's not going to receive more energy just because it has more water. Just because it has more water, it doesn't get more energy from the candle. The same amount of energy went into all three beakers. Okay, the same amount went in, but it's just that one of them had less particles to heat up, and so the temperature increased more. Okay, now we get on to this double glazing question. So I'll continue with this here. We've got a house and it's got double glazing, which is windows. I think we talked about this, right? So you've got these window panes and you've got a layer of air trapped in between them. And we've also got some insulation in the roof. So insulation is anything that is a poor conductor so that the heat cannot escape from the house. Okay, so they had a temperature sensor. They were measuring the temperature, and they had a small lamp, and the lamp is used as a heat source. And when the model house reaches a given temperature, the lamp is switched off. So I don't know if you guys were rushing at this point, but look at that. The model house warms up, and when it reaches a given temperature, we switch the lamp off. So what's going to happen to the house when we switch the lamp off? Look, the lamp is used as a heat source, so if we switch it off, the house is going to cool down. The data logger records the temperature regularly over time. Okay, so the pupils predict that the roof insulation will be more effective than double glazing. So they think roof insulation is going to be better than double glazing. What evidence would support this prediction? What most of you did here was you explained why roof insulation will be more effective than double glazing. But we don't know the answer to that yet because we haven't done the experiment. So they haven't done the experiment, you haven't done the experiment, we don't know which would be more effective. They want to know what evidence you could collect. So the evidence would be if the temperature, so if temperature decreases slower. Now in which one? The roof insulation is going to be more effective, so in roof insulation. So if we compare these two houses, one has roof insulation, the other one has double glazing. We heat them up, we turn off the heat source, and then we see what happens to the heat in the house. If I live in that house, I want the method that's going to be the slowest to cool down, because then I'll be warm longer. So on the graph here, temperature inside the model house, degrees Celsius, room temperature is right here, okay, on this dotted line. We heat up the house. So perhaps we heat up the house. Now we could say we heated it up to here. It's up to us where we want to heat the house. Now look, it says use a solid line to show the graph for double glazed windows. So I'm going to draw a solid line. But what is the question asking me? It's asking me to show the results if the pupil's prediction is correct. And what did they say? They predicted that roof insulation would be more effective. So that means roof insulation should decrease slower. So if I'm going to go down to room temperature with my roof insulation, perhaps it will go something like this. Here the temperature is falling. I've turned off the lamp. Temperature is falling. And it reaches room temperature. But the double glazed windows, in my theory, okay, I think that double glazed windows aren't as effective as roof insulation, so they're going to cool down faster. They're going to get back down to the room temperature, the same point, and they're going to start, because look, it said when the model house reaches a given temperature, the lamp is switched off. So they're both at the same starting temperature, because that wouldn't be fair. So here's this one, but this one cools off much faster. Look, on the x-axis, it's time across here. So this one took less time to cool down. Person living in this house is still cold. Person living in this house at this point, maybe after 1 hour, they're still nice and warm. So this is the graph we were looking for.